For billions of years, two planets in our solar system have been eerily alone. While their cosmic neighbors have whole families of moons, some in the hundreds, Mercury and Venus are solitary worlds, forever circling the sun without a single companion. They are the solar system's orphans. What cosmic curse left these two worlds in perpetual solitude? Was it a violent, fiery past, or just the relentless tyranny of our own star? Well, the answer isn't just one thing. It's a gripping story of gravitational warfare, impossibly narrow windows of opportunity, and a series of cosmic catastrophes. So let's get into the scientific truth behind why the sun's immense power and the violent history of the inner solar system kept Mercury and Venus from ever having a moon. Hello everyone, welcome to another video. Thank you for tuning in. If you are a subscribed viewer, thank you for all the support. If you are new to the channel, consider a like if you really like the video. Please share your feedback in the comments. And if you wish, do let me have the pleasure of knowing which part of the world my viewer is tuning in today in comments below. Our solar system is a place of beautiful imbalance. On one side, you have the giants, Jupiter and Saturn. As of early 2026, Jupiter has 97 officially recognized moons, and Saturn, the undisputed king of moons, boasts a staggering 274 confirmed satellites, a number that jumped dramatically with new discoveries. Farther out, Uranus has 28, and Neptune has 16. Even our red neighbor Mars has two small companions, Phobos and Deimos. And of course, there's Earth, with its one exceptionally large moon. Every single planet from Earth outward has at least one moon. But as we move closer to the Sun, we find a stark, empty void. Mercury and Venus, the first two planets, have none. This is no coincidence. The closer you are to the Sun, the more you're at the mercy of its overwhelming power. To understand why these planets are alone, we have to investigate two very different celestial crime scenes, starting with the one closest to the Sun. Mercury's fate was really sealed by two things: its tiny size and its extreme closeness to the Sun. As the smallest planet in the solar system, Mercury's mass is only about 5.5% of Earth's. That means its gravitational pull is incredibly weak, making it tough to hold on to anything in its orbit. But its size is only half the problem. The real killer is the Sun. Imagine every planet is surrounded by an invisible bubble of gravitational influence called the Hill sphere. Inside this sphere, the planet is the boss. Outside of it, the Sun's gravity takes over and will mercilessly rip any aspiring moon away. Because Mercury is so close to the Sun, orbiting at an average distance of just 58 million kilometers, and because its mass is so low, its Hill sphere is minuscule. For a moon to have a stable long-term orbit around Mercury, it would need to exist in an impossibly narrow Goldilocks zone. Too far, and the Sun snatches it. Too close, and it gets torn apart by Mercury's own tidal forces, the same forces that cause tides on Earth. That stable zone is so narrow it's practically non-existent. So could Mercury have ever even formed a moon? Let's look at the three main ways moons are made. First, there's accretion, where a moon forms from a disk of gas and dust around a young planet, which is how the big moons of Jupiter and Saturn likely formed. But in the early solar system, the intense solar wind from the young Sun would have blown most of the light gas and dust away from Mercury's neighborhood, leaving very little raw material to build a moon. Second, there's capture, where a planet's gravity snags a passing asteroid. This is a leading theory for how Mars got its moons. But for Mercury, this is nearly impossible. Any object that wanders close enough to be captured by Mercury's weak gravity is already deep inside the Sun's powerful gravitational well. The Sun would always win that tug of war. Finally, there's the giant impact hypothesis. This is the leading explanation for our own moon, where a Mars-sized object smashed into the early Earth, and the leftover debris eventually formed the moon. Could something similar have happened to Mercury? It's highly unlikely. Given Mercury's small size, a collision big enough to create a moon-forming debris disk would have probably shattered the planet itself. So for Mercury, the verdict is clear. It was doomed by its circumstances. Too small and too close to the Sun, it never stood a chance. Venus, though, is a much more complex and fascinating mystery. It's often called Earth's twin for a reason. It has about 80% of Earth's mass, giving it a much stronger gravitational pull than Mercury. Its Hill sphere, while smaller than Earth's, is theoretically large enough to hold onto a moon. So, what's the deal? Why is it alone? The answer, some scientists believe, lies in a story of incredible cosmic violence, a tale of a lost moon and a planet spun backward. Unlike Mercury, it's very possible that Venus did have a moon in its distant past. One leading hypothesis suggests that, like Earth, Venus could have experienced a giant impact that ejected enough material to form a moon. For a while, this Venusian moon would have orbited its planet, a silent companion in the early solar system. But then, according to this theory, something catastrophic happened, a second major impact. While the first impact may have created a moon, this second collision could have been so powerful that it fundamentally altered Venus itself, striking the planet at such an angle that it actually reversed its spin. And that is the key to Venus's moonlessness, its slow, backward rotation. Venus spins in the opposite direction of almost every other planet, and it spins incredibly slowly. A single day on Venus lasts 243 Earth days, which is longer than its 225-day year. This retrograde, or backward spin, is a death sentence for any moon in a regular orbit. Here's why. On Earth, the moon's gravity creates a tidal bulge on our planet. Because Earth spins faster than the moon orbits, this bulge gets dragged slightly ahead of the moon. This forward bulge then pulls the moon, giving it a tiny energy boost and causing it to slowly drift away from us by about 1.5 inches per year. But on a backward spinning Venus, the opposite would have happened. A moon orbiting in the normal direction would create a tidal bulge. But because the planet is spinning backward underneath it, that bulge would lag behind the moon. Instead of pulling the moon forward, it would pull it backward, acting as a brake. This process, called tidal decay, would steal the moon's orbital energy, causing it to spiral slowly but inevitably inward. Over millions of years, the doomed moon would have gotten closer and closer until it reached a point called the Roche limit, the distance where the planet's tidal forces are stronger than the moon's own gravity. At that point, the moon would have been torn to shreds, with its remains either forming a temporary ring or crashing down onto the Venusian surface. So the story of Venus might be one of creation and destruction. A giant impact may have given it a moon, but another violent event could have reversed its spin, dooming that moon to a slow, inward death spiral. Venus isn't just a planet without a moon. It may be a planet that killed its own. The loneliness of Mercury and Venus becomes even clearer when you see how other planets held onto their companions. Earth's moon is a product of a perfectly balanced giant impact. The collision was just right. energetic enough to create a massive debris disk, while Earth's gravity and distance from the Sun were perfect for that debris to form into a large, stable moon. Mars presents a different story. Its two tiny moons, Phobos and Deimos, were long thought to be captured asteroids, but their nearly circular orbits have puzzled scientists, leading to competing theories. One newer model suggests that a passing asteroid didn't get captured whole, but was torn apart by Mars's gravity. The debris from that torn-up asteroid then formed a ring, which clumped together to create the two moons we see today, explaining both their asteroid-like look and their stable orbits. And the gas giants, Jupiter and Saturn, they had it even easier. Their immense mass gives them enormous hill spheres, allowing them to act like gravitational vacuum cleaners. They formed their own families of large moons from massive dust and gas disks, and later captured dozens of smaller, irregular moons that strayed too close. Their huge distance from the Sun means solar interference is a minor issue, giving them stable gravitational kingdoms to rule. Each of these planets succeeded where Mercury and Venus failed. They had the right combination of mass, distance from the Sun, and a less destructive history to either create or capture the moons they still have today. For billions of years, the inner solar system has been a gravitational battleground. The story of why Mercury and Venus are alone is a stark reminder of just how hostile the cosmos can be. For Mercury, the enemy was overwhelming and constant. The Sun's relentless pull, combined with its own small size, created a cosmic dead zone where no moon could ever survive. For Venus, the story is possibly one of a violent, tragic past. It may have had a moon, born from a colossal impact, only to have its fate sealed by another cosmic blow that sent the planet spinning backward and dragged its companion to a fiery end. These two worlds stand as silent monuments to the immense power of our star and the chaotic nature of how planets form. They are the solar system's orphans, not by choice, but by cosmic decree. What do you think is the most fascinating aspect of this cosmic mystery? The Sun's overwhelming power, or the theory of Venus's lost, doomed moon? Let us know in the comments below. And if you enjoy unraveling the secrets of the universe, be sure to subscribe for more deep dives into the cosmos. Thanks for watching.